Section 404.8b of the National Electrical Code requires a permanent barrier between adjacent devices, where the voltage can exceed 300 volts between them. It's important to understand that even when circuits are derived from a dry-type transformer, a voltage potential exceeding 300 volts can exist between a 120-volt circuit and a 277-volt circuit. This is because the circuits are not electrically isolated from each other. The neutral conductor of the 120-volt circuit is connected to the neutral conductor of the 277-volt circuit at the transformer. Because of this connection, if there is a fault on the 120-volt circuit, current can flow through the neutral conductor to the 277-volt circuit, and vice versa. Consider a scenario where a 120-volt circuit and a 277-volt circuit are brought into the same box. One circuit powers lighting and the other powers a restroom exhaust fan. In this situation, the voltage between the two circuits can be as high as 277 volts. This voltage level is close to, but less than the 300-volt threshold specified in section 404.8b. However, if the voltage between the circuits ever exceeds 300 volts, then a permanent barrier is required. This is to prevent accidental contact with energized parts. The purpose of the barrier is to provide a physical separation between the two circuits, reducing the risk of electrical shock. If a fault occurs on one circuit, the barrier will help to prevent a fault current from flowing to the other circuit. The barrier must be made of a non-conductive material, such as plastic or fiberglass. It must also be securely fastened in place so that it cannot be easily removed. The size of the barrier will depend on the size of the box and the number of circuits that it contains. It is important to consult the National Electrical Code and local electrical codes for specific requirements. In the specific example of a 120-volt circuit and a 277-volt circuit in the same box, even if they are derived from a dry-type transformer, a permanent barrier may be required to comply with section 404.8b. The key takeaway is that the neutral connection between the circuits allows for a potential voltage difference that necessitates a barrier for safety. Always prioritize safety and adhere to the National Electrical Code guidelines when working with electrical systems. When dealing with electrical installations, safety is paramount. Understanding the voltage potential between different circuits is crucial for preventing electrical hazards. Even if circuits are derived from a dry-type transformer, they are not entirely isolated, and a voltage difference can exist between them. The National Electrical Code section 404.8b addresses this issue by requiring a permanent barrier between adjacent devices, where the voltage can exceed 300 volts. The question arises whether a 120-volt circuit and a 277-volt circuit in the same box can have a voltage potential exceeding 300 volts. Even though they may be derived from a dry-type transformer, the answer is yes, it is possible. The reason is that the neutral conductor of the 120-volt circuit is connected to the neutral conductor of the 277-volt circuit of the transformer. This connection creates a path for current to flow between the two circuits in the event of a fault. In the given scenario, where one circuit powers lighting and the other powers a restroom exhaust fan, the voltage between the two circuits can be as high as 277 volts. While this is less than the 300-volt threshold specified in section 404.8b, it is still important to consider the potential for voltage fluctuations or other factors that could cause the voltage to exceed 300 volts. Therefore, it is recommended to install a permanent barrier between the 120-volt circuit and the 277-volt circuit in the box. The barrier should be made of a non-conductive material and should be securely fastened in place. It should also be sized appropriately to provide adequate separation between the circuits. By installing a permanent barrier, you can significantly reduce the risk of electrical shock and ensure compliance with the National Electrical Code. In summary, even when circuits are derived from a dry-type transformer, a voltage potential exceeding 300 volts can exist between them. To comply with section 404.8b of the National Electrical Code, a permanent barrier should be installed between adjacent devices, where the voltage can exceed 300 volts. This is especially important when working with 120 volt and 277 volt circuits in the same box. Always prioritize safety and consult with a qualified electrician when working with electrical systems. Let's dive deeper into the technical aspects of this situation. The dry-type transformer, while providing isolation between the primary and secondary windings, does not isolate the neutral conductors of the circuits derived from the secondary side. The neutral is typically bonded to ground at the transformer, creating a common reference point for both the 120 volt and 277 volt system. This common neutral connection is what allows for the potential voltage difference between the two circuits. To further illustrate this point, consider the following scenario. Imagine a fault occurs on the 120 volt circuit, causing a surge of current to flow through the neutral conductor. This surge of current can also affect the 277 volt circuit, potentially raising its voltage level. Conversely, a fault on the 277 volt circuit can also affect the 120 volt circuit. This interconnectedness of the neutral conductors is why a permanent barrier is necessary to prevent accidental contact with energized parts. The barrier acts as a physical separation, reducing the risk of electrical shock. When selecting a barrier material, it is important to choose a non-conductive material that is suitable for the environment in which it will be installed. Common materials include plastic, fiberglass, and other insulating materials. The barrier should also be sized appropriately to provide adequate separation between the circuits. The size will depend on the voltage level of the circuits and the spacing requirements specified in the National Electrical Code. In addition to installing a permanent barrier, it is also important to follow other safety precautions when working with electrical systems. These precautions include wearing appropriate personal protective equipment, such as gloves and eye protection, and energizing circuits before working on them. It is also important to properly ground all electrical equipment to provide a safe path for fault current to flow. By following these safety precautions, you can significantly reduce the risk of electrical shock and ensure a safe working environment. In conclusion, the potential for voltage differences between circuits derived from a dry-type transformer necessitates the use of permanent barriers in certain situations. Section 404.8b of the National Electrical Code provides specific guidance on when these barriers are required. By understanding the technical aspects of this issue and following the recommended safety precautions, you can ensure the safety of yourself and others when working with electrical systems. Let's explore some additional considerations related to this topic. Firstly, it's important to understand the concept of voltage to ground. In a typical 120 volt system, the voltage to ground is 120 volts, meaning that the potential difference between the hot conductor and ground is 120 volts. Similarly, in a 277 volt system, the voltage to ground is 277 volts. When these two systems share a common neutral, the voltage difference between the hot conductor of the 120 volt circuit and the hot conductor of the 277 volt circuit can be as high as 277 volts, or perhaps higher under certain conditions. This voltage difference is what necessitates the use of a permanent barrier. Secondly, it's important to consider the potential for transient voltage surges. Transient voltage surges can occur due to various factors such as lightning strikes, switching operations, and equipment malfunctions. These surges can significantly increase the voltage level of a circuit, potentially exceeding the 300 volt threshold specified in Section 404.8b. Therefore, it's important to take measures to protect electrical systems from transient voltage surges. This can be achieved by installing surge protective devices (SPD) at strategic locations throughout the system. SPD are designed to divert surge current away from sensitive equipment, protecting them from damage. Thirdly, it's important to consider the potential for harmonic currents. Harmonic currents are non-sinusoidal currents that can be generated by various types of electronic equipment, such as computers, variable frequency drives, and LED lighting. These harmonic currents can distort the voltage waveform and cause a variety of problems, including overheating of electrical equipment, nuisance tripping of circuit breakers, and interference with communication systems. To mitigate the effects of harmonic currents, it's important to use harmonic filters or other mitigation techniques. These filters are designed to reduce the amplitude of harmonic currents, improving the power quality of the electrical system. In addition to these technical considerations, it's also important to be aware of the legal and regulatory requirements related to electrical safety. The National Electrical Code is a widely adopted standard for electrical safety, but it is not a law in itself. However, many local jurisdictions have adopted the National Electrical Code as law, making it legally binding. Therefore, it's important to be familiar with the electrical codes and regulations in your area and to comply with them. Furthermore, it's important to obtain the necessary permits and inspections before performing any electrical work. This will ensure that the work is performed safely and in compliance with the applicable codes and regulations. In summary, the potential for voltage differences between circuits derived from a dry-type transformer necessitates the use of permanent barriers in certain situations. Section 404.8b of the National Electrical Code provides specific guidance on when these barriers are required. By understanding the technical aspects of this issue, considering the potential for transient voltage surges and harmonic currents, and complying with the applicable codes and regulations, you can ensure the safety of yourself and others when working with electrical systems. Remember to always consult with a qualified electrician when performing any electrical work. It's also important to understand that the requirement for a permanent barrier is not solely based on the normal operating voltage of the circuits. The code takes into account the potential for abnormal conditions, such as voltage spikes or surges, that could cause the voltage between the circuits to exceed 300 volts. This is why the code specifies that a barrier is required where the voltage can exceed 300 volts, not just where the voltage is 300 volts. Furthermore, the type of equipment connected to the circuits can also influence the need for a barrier. For example, if the 120-volt circuit is connected to sensitive electronic equipment that could be damaged by a voltage surge from the 277-volt circuit, then a barrier would be even more important. Similarly, if the 277-volt circuit is connected to equipment that could pose a safety hazard if it were to malfunction due to a voltage surge from the 120-volt circuit, then a barrier would be essential. In addition to the physical barrier, it's also important to ensure that the wiring methods used for the circuits are appropriate for the voltage levels involved. For example, the conductors used for the 277-volt circuit should be rated for at least 300 volts, and the conductors used for the 120-volt circuit should be rated for at least 150 volts. The wiring method should also be installed in accordance with the National Electrical Code, including the proper use of conduit, junction boxes, and other fittings. Furthermore, it's important to properly ground all electrical equipment to provide a safe path for fault current to flow. The grounding system should be installed in accordance with the National Electrical Code, including the proper use of grounding electrodes, grounding conductors, and bonding jumpers. A properly installed grounding system can help to prevent electrical shock and minimize the risk of equipment damage in the event of a fault. In addition to the technical aspects, it's also important to consider the human factors involved in electrical safety. Electrical work can be dangerous, and it's important to be aware of the risks involved and to take appropriate precautions. This includes wearing appropriate personal protective equipment such as gloves and eye protection, and energizing circuits before working on them. It also includes following safe work practices such as using insulated tools and avoiding contact with energized parts. Furthermore, it's important to be properly trained in electrical safety and to stay up to date in the latest codes and regulations. Electrical codes and regulations are constantly evolving, and it's important to be aware of the changes and to adapt your work practices accordingly. In summary, the requirement for a permanent barrier between adjacent devices where the voltage can exceed 300 volts is an important safety measure that should be taken seriously. By understanding the technical aspects of this requirement, considering the potential for abnormal conditions, and following safe work practices, you can help to prevent electrical shock and minimize the risk of equipment damage. Always consult with a qualified electrician when performing any electrical work, and always prioritize safety. It is essential to remember that electrical systems are complex and can be dangerous if not handled properly. Therefore, it is always best to err on the side of caution and to seek professional assistance when needed. A qualified electrician will have the knowledge, skills, and experience to safely and effectively install, maintain, and repair electrical systems. They will also be familiar with the latest codes and regulations and will be able to ensure that your electrical system is in compliance. In addition to the technical aspects, it is also important to consider the environmental factors that can affect electrical safety. For example, moisture, humidity, and temperature can all have an impact on the performance of electrical equipment and can increase the risk of electrical shock. Therefore, it is important to protect electrical equipment from these environmental factors. This can be achieved by using enclosures that are rated for the environment in which they will be installed. For example, if the equipment will be installed in a damp or wet location, then it should be installed in a waterproof enclosure. Similarly, if the equipment will be installed in a hot or cold location, then it should be installed in an enclosure that is rated for the temperature range. Furthermore, it is important to regularly inspect electrical equipment for signs of damage or deterioration. This includes checking for cracked or broken insulation, loose connections, and corroded parts. If any damage is found, then the equipment should be repaired or replaced immediately. In addition to the physical safety aspects, it is also important to consider the cybersecurity aspects of electrical systems. Modern electrical systems are increasingly interconnected and rely on digital technologies for control and monitoring. This interconnectedness can create vulnerabilities that can be exploited by hackers. Therefore, it is important to take measures to protect electrical systems from cyber attacks. This includes implementing strong passwords, using firewalls, and keeping software up to date. Furthermore, it is important to train employees on cybersecurity best practices. In summary, electrical safety is a multifaceted issue that encompasses technical, human, environmental, and cybersecurity aspects. By understanding these aspects and taking appropriate precautions, you can help to prevent electrical shock, minimize the risk of equipment damage, and protect electrical systems from cyber attacks. Always consult with a qualified electrician when performing any electrical work, and always prioritize safety. And do not forget to follow the National Electrical Code.